Yeah, thank you for coming here. It was exciting to hear everybody, all the partners talking about their architecture, their numbers. Very exciting. So I almost think I don't need to speak. But let me just talk from the perspective of the ARM architecture team and also the line of business for the infrastructure on how we are supposed to support the partners to address the HPC and the related infrastructure market. Some of these information are related to the launch we did in October. So the ARM Neoverse brand is a new brand which was announced in October of last year. So if you look at the infrastructure from the perspective of not only the servers, but also including the top of rack switches, the cellular base stations, gateways, and the routers, you can see that over the last 6 to 7 years, ARM has progressed a lot. And we have the unit market share now reaching about 27%, and that is actually the largest in the industry. And also during this time, I think we are also experience a big change from how we are doing the cloud and the device kind of communications. Today we have the media content distribution and consumption that is the main driving force for the infrastructure design. So it's a pretty simple cloud data center on the one end, and then you have billions of devices on the other end, and the the information passing are usually the media content, the videos and such. But in the future, when we have trillions of devices, the network bandwidth would be an issue if you continue to utilize today's design. So we think that the edge is going to be very important to help filter and react to the data that you collect from the trillions of devices. And certainly 5G plays an important role to increase the network bandwidth. And then from the edge to the cloud data center, you would only pass the critical data to the to deep in the cloud. So the ARM Neoverse is going to be the brand for the cloud to edge infrastructure foundation. So compared to the Cortex brand that everybody is familiar with, Cortex is going to be on the client and the embedded space. For the Neoverse, it's going to address three parts. One is the high performance secure IP and architecture, which applies to the HPC side quite a bit. And then certainly, just as any of the designs, we certainly enable the diverse solutions and the ecosystem. Ecosystem is critical, for the HPCs as well. And then we want to have the solutions that are scalable from the hyperscale data centers all the way to the edge. So what we have announced in October is also this roadmap where, for the current systems based on the 16 nanometer, we are designing for 3 future generations, the Aries, the Zeus, and the Poseidon systems over the next 3 years. And as you see from the process perspective, you go from 16 to 7 to 7 nanometer plus to 5 nanometer. But also during these transitions, we are providing this guidance that we are going to be able to have 30% of performance increase from generations to the next, plus additional new features. So this is actually very important. And also, this Neoverse architecture is not only the micro architecture or the IP designs. It also includes everything that all our partners are designing and offering to the industry, using the world-class solutions designed at multiple possibilities of microarchitecture levels. You could use your own microarchitecture. You can also leverage what ARM provides. And all the solutions designed around the secure-centric and compliance model. So in this picture, you can see that ARM would provide the Neoverse CPU and system IP, right? At the same time, this CPU and IP architecture includes a lot of the architecture that you are familiar with, like trust zone. For security. And then we also work with the industry for the platform standards because we want to address the usage of the I/O technologies like PCIe and C6. Also, in the security area, we are looking at security standards like those coming from the TCG or the OCP. And also looking at some of the guidances from the organizations like NIST. And then we work with the community. So I would like to emphasize that a lot of work, including the HPC work, we depend on the community, the open source community, as well as partners working with the ISVs. So we develop secure ARM platforms based on these designs, and then we work with partners, including Lenaro, on providing reference implementations in firmware and in Linux kernels and applications. So we also designed a certification program for the server systems, and as Fujitsu was mentioning early on today, we have defined a few specifications, and we defined test suites to certify systems, so the users can have a uniform user experience, and also, like Fujitsu was saying, we would have guaranteed binary compatibilities for a lot of the modules. And so why do we do standards? I think in the embedded space or the client space, sometimes we didn't do that in the ARM ecosystem. But for servers, we think that because the ARM's architecture, we want the architecture to continue to support the diverse variety of solutions. But at the same time, even though diversity is good, but uncontrolled diversity is not good for the server ecosystem, because it's very difficult for one company to own everything, from the hardware all the way through to the applications. So we want to make sure the servers are boring enough for the users to install the OSs that would just work. So we would modify the operating systems to suit the hardware. Is not a very viable solution. So this philosophy is actually kind of opposite to what the embedded space is about. So for servers, we rely on the standards to solve this problem, and we defined a couple of specifications, as Fujitsu was mentioning this morning. So SBSA is the server-based system architecture, which defines the minimum hardware requirements for the ARM servers. So you can certainly add on top of it additional feature sets, but you have to have the support for the minimum hardware first. And then also SBBR was mentioned. This is the server-based boot requirements. So this is the baseline firmware interfaces. Again, you can support more additional features, additional interfaces, but you have to support these interfaces. And for SBSA and SBBR, both of these specifications are developed not by ARM alone, but by a community of more than 46 companies together. And these includes everybody from the silicon providers, BIOS vendors, operating system vendors, application vendors, across the board. So we leverage the industry standards, even if it is created by Intel or any other companies. We leverage these industry standards as much as possible. We don't want to recreate the wheel, reinvent the wheel. But at the same time, if there are gaps, especially ARM platform architectures are not exactly the same as x86, right? Interrupt controllers and such are different. So we would create additional ARM specifications to fill in the gaps. And we support industry new standards like C6 I mentioned. And then, specification is not very useful if you don't have reference implementations or you don't have deployments. So reference implementation is the first step to enable the deployment. So we work with the community to participate in the development in open source projects, not only Linux kernel, but EDK2 for firmware, trusted firmware for the lower levels, and then we also are working on the OpenBMC for the management controller. So we work with the OS vendors that are not open source as well, including Microsoft. So like I mentioned, specification alone is not very useful. So we have a team created the test suite, which is basically allow you to check against the specifications for your systems. And we created this server-ready logo program for certification. So if you design a system, whether it's for cloud data center or HPC, if you want, you can work with us to certify your system for server ready, which means that if you comply to these standards, you would have a uniform user interface for installing your OS and applications. And last October, when we launched the Neoverse program, we also launched the server ready, and we have a large amount, vast majority of the silicon partners and ODMs working with us. So a lot of the partners here in the room already have the systems certified. So that was a very nice experience toward the end of last year. And then in terms of the diverse solutions and the options, we offer a lot of design options within the ARM ecosystems. Starting from the ARM IPs, right? We have the CPU designs, not only for high performance CPUs but also for data planes and fabric and such. And we also provide ARM architecture designs. We also work with the industry on the accelerators, memory, I/O, right? And also we work with the foundries a lot. TSMC, of course, Samsung and such. And also we work again with the community on the common software platform and ecosystem. So when we launched the Neoverse, we certainly got endorsed by a robust ecosystem. A lot of the silicon cloud platform and operators were all supporting what we do. And also, it was endorsed by a broad and growing open networking and server ecosystem. So this infrastructure new brand is not just for servers, but it's also for storage and networking and edge devices as well. So when I mentioned the scalability of the design, so the brand is covering all the way from the hyperscale and HPC to the edge. So the IP that we are providing are basically designed in a very modular way. So you can address the edge side by choosing an implementation that has very few cores, maybe even not much cache. and limited bandwidth for memory and so on. But on the other end, when you go to the HPC and cloud data centers, you can choose all the way up to 128 cores for your design for the CPU, and a lot of memory and high bandwidth type of choices as well. So one solution uh, provided by ARM, and you can choose to deploy in uh, anywhere between the hyperscales all the way to the edge. So the other thing, because this is the HPC workshop, so one message that ARM would like to offer is that we think the ARM based HPC is not just a talking point; it's for real, right? So we actually have seen deployments already, and this is the example that Jill mentioned earlier in the opening keynote, that this is the Astra program. Um, so as the name Astra is actually very interesting. It means from through hardship to stars. But it basically shows the effort that HPE and ARM and others, Marvell, Cavium, work together to build this system. So it's already deployed in the Sandia National Lab, and as was mentioned earlier, this was numbered 203 in the top 500 list in 2017. 2018, it becomes 204. I think there was one in the middle. It's a system with 2,592 nodes with the HPE Apollo 70 system, and so it has a total of 5,184 CPUs, uh, and if you count all the cores, it becomes 145, more than 145,000 cores, and the peak performance is 2.3 pflops. And it uses the Marvell Thunder X2 SoC with 28 cores, and it has 128 gigabyte per node for the memory. Utilize the Mellanox InfiniBand devices. Red Hat Rio is actually certified on that machine. And then it has some all-flash Lustre storage as well supported. So very exciting. It's for real, so it's already deployed. And I'm also very happy to actually hear from all the partners today with all the exciting numbers that are coming up. I hope that these will transform into the real systems being deployed in the next few years. And that's basically it from my side.
Any questions?